talking about the exciting world of rational exponents. Okay, and we talked about how you can rewrite them, and if you have a 1 over a value, that is going to be the root. 1/2 is a square root, 1/3 is a cube root. Okay, and then we also talked about how you can remember the root is on the bottom because roots grow on the ground. The power's on top because if you're on top, you got the power. And we also did A, B, and C, and then we have to do D. Okay, so D is going to have a negative exponent. And anytime you have a negative exponent, you can rewrite it to make it positive. You never want your final answer to have the negative exponent in there. Okay, so we're going to write this in radical form, but before we do that, we want to make sure that it's positive. So the first step is going to be writing 1 over 625 to the 3/4. And really, as you guys practice this, you'll do this step first. So 4 is the root. Now, if we're doing this without a calculator, we're doing the 4th root, okay? We aren't going to want to do 625 to the 3rd, because remember you have the option of putting it inside or outside the power. So we're going to want to put it outside. Is the 4th root of 625 one of our perfect roots that we wrote on the front side? Yeah, 5 to the 4th power is 625, so this would be 1 over 5 cubed, and we know 5 cubed is, yes, 125. So 1 over 125 is your final answer. Okay, now for example 4, this should say write each expression using rational exponents. We're not going to do radicals in the exponents, only fractions. Okay, so if you can simplify these, you will. So sometimes they'll simplify, sometimes they won't. So let's look at this one. This is the 8th root of 13 to the 4th power. Okay, and then just remember that your root is always going to be the index there. Okay, so it's a to the m over n. Okay, where n is the root. So the n in this case is what number? What's the n in this case? The 8. 8 is the root. Okay, which means the m is the 4. So when you rewrite this, it's 13 to the 4 over 8. Now this does reduce, so we have to reduce it. That would be 13 to the 1/2. Now when you get in this situation, remember 1/2 is the same thing as the what? Square root. Now, if this simplifies, okay, then you would bring this down, but can you simplify the square root of 13? No. Okay, so doesn't simplify. So leave as a rational exponent. Okay, because it does say to write it using rational exponents, and then once you simplify, if it doesn't simplify, you can just leave it like that. Alright, and then for B, we have the 5th root of 3, and that whole quantity is raised to the 15th power. So I want you to rewrite that. And then simplify as much as possible. see most of you have it. Remember that whatever the root is, that goes on the bottom of the fraction. So it's 15 over 5. Okay, we got that far? And then 15 divided by 5 is? Yeah, and 3 cubed, we can simplify that. What's that? Yeah, so that'll be your final answer. Okay, so you do the 3 cubed, because you can absolutely simplify. So 27 will be your final answer for that. All right, now we're going to talk about some properties, and the good news is that you are already familiar with most of these properties. It's just the practice problems might be a little different than what you're used to doing in Algebra 1, because you do learn about these properties in Algebra 1, and we've actually even talked about some of them this year. So we're going to talk about properties of rational exponents. Notice that it says for all non-zero real numbers, okay, and then the rational numbers m and n. Okay, so the first one is the product of the powers, and that is going to be very similar to the quotient of the powers. Okay, so if you have a to the m times a to the n, what do we do with the exponents? Add them. So if you have the same base, you are going to add them together. Okay, now the example they give you here is going to simplify all the way. I'm going to give you an example, and we're going to look at both of those. So you're going to have a few different types. So the example we have is 5 to the 1/2 times 5 to the 2/3. Okay, so when I say these are different than the ones that you did before, in Algebra 1, you probably shouldn't have to do with fractions and the exponents. You probably just had like 5 squared times 5 to the 3rd, and then you added it that way. Okay, so now when you're adding and you have a fraction in the exponent, what do we have to make sure we do if we're adding those together? If we're adding 1/2 and 2/3. Yep. What's the denominator going to be? 6. Okay, so if it's 1/2, what goes on top of 6? 3. 3, 6. To get from 3 to 6, you multiply by 2. So 2 times 2 is? Yay. Good work. Okay, so then you have 5 to the power of 7 over 6. Okay, and you can leave your final answer like that. The 6 root of 5 is not going to simplify, okay, so we don't have to worry about simplifying in that step. For this, the 12 to the 1/2 times 12 to the 3 over 2, when you added, you got 4 over 2, which simplified to a whole number, so you would simplify that. Okay, so that's an example of what it would look like if you could simplify. All right, and then for the quotient, that's when you have a fraction, so a to the m over a to the n. And we just practiced this in early chapter 5, right? 5-2, 5-3. So we have a to the power of m minus n. That's when you subtract them. Okay, so we have 3 to the 2/3 over 3 to the 1/3. Okay, so can you simplify that one? That one should be pretty quick, because you have like terms already, right? So when you subtract them, 2/3 minus 1/3 is what? Yeah, 3 to the 1/3 power. And again, you can't simplify that, so you're just going to leave it. Here's an example of one that does simplify. So you get 125 to the power of 1/3. Remember, 1/3 is the same thing as doing what to 125? Taking the cube root. And we know the cube root of 125 does simplify. So this simplifies to 5. Okay, so this would be something where you could simplify. This is an example where you would leave it with the fraction, okay? All right, the power of a power. That's another one that you've done before. Power of a power. And that's where you have a to the m, and that is raised to the nth power. That is when you multiply. Is there any way that you guys remember which one you add, which one you multiply? Because these are probably the two most mixed up of all of them. I always remember this one has 2 of the base in it. This one only has 1. That helps me differentiate them. And really, this one you will have the parentheses. Okay, so your example is 3 to the 1/2 to the 2/3. 3 to the 1/2 to the 2/3. Alright, so let's multiply this. So when you multiply fractions straight across, 1 times 2 is 2, 2 times 3 is 6, but then that reduces. 2 over 6 reduces to 1/3. So this one is 3 1/3 too. Alright, the next one is the power of a product. And then we have a power of a quotient. And these two are very similar to each other. So if you have a power of a product, that means you have 2 values multiplied together, raised to the same power. Okay, so when that happens, you can distribute the power. Now, sometimes people confuse that with addition. It doesn't work with addition, it only works with multiplication. So, I like to put a little note in there, if you have a plus b to the m power, that does not equal a to the m, or plus b to the m, that's not true. And an easy way to relate that to something that we've studied this year is when you have something like x plus 3 squared, right? This is not equal to x squared plus 9. What do you have to do in this situation? You have to FOIL it out, right? So if you were to FOIL, it would be x squared plus 6x plus 9. So not this. You can't distribute like that. Okay, if it's a binomial. Alright, so let's do an example of this one. Okay, so you have 9 times 64 to the power of 3 over 2. Okay, so and there are 2 ways you could do this, okay? So you could do 9 times 64 and then do that to the 3 over 2 power. But you can also split this up into more manageable pieces, okay? So this would be 9 to the 3 over 2 times 64 to the 3 over 2. And then we are going to simplify this part. So if 2 is on the bottom, that's what? What does that 2 on the bottom of the fraction mean? Yep, so we're going to do the square root of 9 raised to the 3rd power times the square root of 64 raised to the 3rd power. Okay, well we know the square root of 9 is 3, so this is 3 cubed times 8 cubed. So it would be 27 times, and then if we're doing 8 cubed, that's not something I know off the top of my head, but I do know 8 squared is what? 64. So to find a cubed, I just have to do 64 times what? Times 8. Yeah? Oh, sorry, who's here? Yes. Oh, no, he's not here, I think. No. Sorry. Thanks. Okay, and we're going to multiply. So you can do this one of two ways. You could do 8 times 6 and then 60, 8 times 4. Or do you guys like doing it the old school way? Yeah, you like that way better? Okay. So 27 times 5, 12. And then we will have to multiply that. So let's do that together. So 5, 12 times 27. So 2 times 7 is 14. Carry the 1. That will make that 8. 7 times 5, 35. Put in my placeholder. And then 2 times 2 is 4. 2 times 1 is 2. 2 times 5 is 10. Add straight down. So oops, sorry, I should start from the back. So 4, 2, 8, 13. All right, so 13,824 is our final for that one. So that one you can simplify out all the way there. Okay, this is another one where they simplified this out, not as intense as this one, right? This is just 1/2. Square root of 16 is 4. The square root of 25 is 5. 4 times 5 is 20. Okay. And this one I think it's really clear to see. Instead of multiplying 16 times 25 and doing the square root of that, we can break it up into more manageable pieces. And then of course, when you're dealing with the quotient, you're dealing with your fraction. So if you have a over b to the m power, this is where you distribute to the numerator and to the denominator. Okay, so if you have 8 over 27 to the 1/3 power, remember 1/3 is the same thing as what? The cube root. So 8 to the 1/3 over 27 to the 1/3. If you want, you could just skip right to this step. Cube root of 8 over cube root of 27. Or when that starts clicking that it is the cube root, you can just go right here. So this would be 2 over 3. So 2/3 is your final answer. Thank you. Okay. So you're going to simplify these expressions. So we've done some examples. Hi.
I have something in first, right?
Oh, yeah. Yeah. Thank you.
You're welcome.
Okay, and I'm going to have you guys try these without me. So 7 to the 7/9 times 7 to the 11 over 9. And then 16 to the 3 over 4 over 16 to the 5 over 4. And then negative 8 to the negative 1/3. Okay, so I want you to try those. You can check in with your row. You can check in with your row when you're done, or if you are getting stuck on something. Then check in. Alright, let's check in. So for part A, just give me a 0 or a 5. 5 being you're very confident that your answer is correct. Where are we at for A, for part A? Okay, good. Lots of confident people. And you had a common denominator, right? So what was your fraction? When you added, what did you get for your fraction? 18 over 9. Okay, good. So 18 over 9 simplifies to 2. 7 squared is 49. Okay, great. All right, same thing for B. Where are we at from 0 to 5? 25. So this one, you did have to deal with what? A negative exponent, yes. Okay, so the subtraction probably went well, right? And you got negative 2 over 4, which reduces to negative 1/2. So let's deal with the negative first. How do we change it from negative to positive? Put it over 1, yep. So we make the fraction. And then 16 to the 1/2 is the same thing as doing what to it? Yep, and the square root of 16 is 4. Now you do not need the plus or minus in these cases. You only need the plus or minus if you are solving for something, or if it's asking you to find all of the possible roots, which is what we did earlier this week. So if you're not solving for an unknown, this 1/2 does need a square root, and that number underneath with the positive on the outside means that it's going to be positive 1/4. Okay? All right, so now in case you were unsure about the negative exponent here, now hopefully we know the correct step. So the first thing we want to do is put this over 1, and then this changes to a positive 1/3, which is the same thing as a cube root. Now, can you take a cube root of a negative? Yeah, any odd root of a negative is fine. What is the cube root of negative 8? Negative 2. Yeah, so this would be negative 1 over 2. And that will be your final answer. Okay, what questions do you guys have for me on that part? Okay. All right, then we are going to do an application problem today. Good standard test practice. So we have radium-226, and that's a form of a radioactive element, and it decays over time. So you have an initial sample, has a mass of 500 milligrams, and then the mass of radium-226 remaining from the initial sample after T years is given by an equation. So this is something that will be given to you in the problem, okay? So I'm going to give it to you. It's 500 times 2 to the power of negative T over 1600. So it's given by 500 times 2 to the negative T over 1600. So this equation is given to us in the problem. To the nearest milligram, how much radium-226 would be left over after 800 years? Okay, so when I'm figuring this out, I do like to highlight what my question is. So what I'm trying to find is how much radium-226 would be left over after 800 years. And when it's saying how much, this is different than some of the other questions that we've dealt with before with decaying, right? We did the decaying and the half-life, but instead of how much, it usually said how long, and we knew that we were finding the time. Okay? We're not going to do that today, because we would need logs to do that, and we're working with radicals. So the how much means how much is the remaining mass. That's what we're trying to find. And they do tell us to find it to the nearest milligram. So we'll be doing some rounding there. Okay, and then I know that the equation is given, but they tell you that the initial sample is 500 milligrams. So you can see that in the equation, a very similar place to when we did our half-life. And it says the mass remaining after T years is given by this equation. So the mass remaining, okay, after T years is given by this equation. We have to find how much radium-226 would be left over after 800 years. So this 800 years, what am I going to be doing with that? Plug in for T. So that's going to be your 800. Okay, so there's no equal sign here, but they said that it's the mass remaining. Okay, so the mass remaining is what's equal to 500 2 to the negative t over 1600. So we're just going to substitute in 800. And really, the parentheses around it, it's the same thing as doing times 2 to the negative 800 over 1600. Okay, you're going to do the exponent before you multiply. So you're following the order of operations, so that's fine. In 800 over 1600, what is that ratio? Yeah, so this will be negative 1/2. So of course, if it's a negative, what do we have to do with that? Yep, so it would be 500 times 1 over, do we also know what the 1/2 is going to change to? Yep. So if this is the square root of 2, we can rewrite this. So think of this as over 1, right? 500 over root 2. Okay? Now, if this was on a calculator portion, I would let you just do this. I would just let you divide. Get rid of that. Divided by square root of 2. And then what did it say we have to round to? The nearest milligram. So you would have, if you're looking at the nearest milligram, that's the nearest whole number, 0.5, dot, dot, dot. So this would be about 354 milligrams. Okay, but if this was on a no calculator section, okay, then you would have to give this to me as an exact value. Okay, so if this is an exact value that you need, and you had to simplify it, what would we have to do? Yeah, good. You guys remembered your vocab word. And rationalize, which means I have to multiply by what? Yes, and this is the square root, so remember, for a square root you need 2. So this is like 2 squared. So you have 500 root 2 over 2. Now, when you have 2 numbers on the outside that simplify, you simplify them. You can't simplify what's inside a radical and what's outside, but what's outside is fine. What's 500 divided by 2? Yeah, so this would be 250 root 2. This would be your exact answer. Okay, so we're going to look at our calendar and the next few things coming out. And then you guys are going to have time to work on your homework.